Bismillahirrahmanirrahim. Okay, my students, I have a question here from November 16, variant 42, and it's a sixth question. Okay, now the question says there is a van of mass 3,000 kg, and it has a trailer with this, which has a mass of 500 kg. Okay, I've mentioned the masses over here. Okay, and then it says this. They are moving at a constant speed of 25 meter per second. So you need to underline the word constant speed. When there is a constant speed, that means you can take all the forward forces equal to the backward forces. Okay. And then he says there is a constant resistance to the motion, 300 Newton to the van and 100 Newton to the trailer. So I've mentioned them in green, 300 Newton the resistance on the van and 100 Newton on the trailer. So now it says find the power of the van's engine. Okay, so the van's engine is obviously taking it towards this direction. If I take this as a system over here, right now I can take the collective mass to be 3,500 kg. I can take the collective frictional force as 400 Newton. There is no need to involve this tension right now because they are both equal and opposite to each other. So I would say that the forward force is going to be to find the power. So just to recall the formula, power is equal to F into V, and this F is the forward force, the driving force. So this driving force is going to be power over V. Okay, so the power we have to find, that is P, and the speed, it is 25. Okay, that is the forward force minus the backward force. These, I will add up these two forces, that is going to be 400 newtons, and the mass is collective mass I'll take, that is going to be I think that is since the acceleration is 0, so I'll just put that equal to 0. I don't need to add up the masses because the acceleration is 0, it is moving at a constant speed. So this gives me the power of the engine, that is going to be 25 times 400. Okay, so that is, I think, 10,000 watts. That is the power provided by the engine. Okay, now the next it says write on the tension in the cable. So for the tension in the cable, you can just focus on this part, okay, because this trailer is also moving at a constant speed. So the forward force is this T and the backward force is 100. So you can simply say that T minus 100, that is equal to 0. So the tension in the cable is going to be 100 newtons. Okay, I hope you understood this. I am going to move towards the next part. Okay, in the next part it says the van reaches the bottom of a hill inclined at 4 degrees. So here it is 4 degrees. Okay, and to the horizontal with speed 25 meter per second. So here that same speed we had here, that 25 meter per second. So it reaches the bottom of a hill at this speed, and then it says the power of the van's engine is increased to 25,000. Now the power is 25,000 watts now. Okay, now it says in the third part, assuming that the resistant forces remain the same. So here you had a resistance of 300 newtons, and here we have a resistance of 100 newtons. Okay, the same, we'll find the tension in the cable. Okay, so now let me show this here, the tension in the cable. Okay, find the tension in the cable at the instant when the speed of the van up the hill is 20 meters per second. So that means, like, for example, we are here the speed is 20 meters per second. So we have to find out that how much is the tension in the cable when the speed is 20 meters per second. Okay, now this is more like a question on that frictional force and F equal to ma thing. Okay, so the only part of the work energy power that is going to be used here, that is to determine that how much is the forward force at the instant then when it is moving at this 20 meters per second. Okay, so let me find that out. That power is equal to F into V. Power is this time 25,000 and the speed is 20. So the forward force that we calculate over here, that is going to be 1250 newtons. Now the work energy power thing is over now, and this is a question on F equal to ma and the frictional force and the all the laws of the Newton over here. Okay, so I'll be showing this weight downward over here. Its weight is 30,000. Okay, and I have to resolve this so that I can find out that how much is the weight acting downwards. So the weight is going to be 30,000 sine 4, and here the weight is 5,000, okay, newtons, and this component of the weight is going to be 5,000 sine 4. We shall have two equations from this because these are two particles connected together, and we shall solve those two equations simultaneously to find this T. So the only thing that we use from the work energy power, that was to determine that what is the forward force right now. Okay, so guys, for the van, I will have that the forward force is 1250 minus, I'll be writing down all the backward forces over here. First of all, there is a backward force 300 Newton, that is a frictional force. Then there is the T, this is in this cable, this T is pulling this backward, okay, because of this trailer's motion, okay. And then we have its weights component, so that is going to be 30,000 sine 4, and its mass is 3,000, and the acceleration is a. That is our first equation. Now if you look at the trailer, so you will see that the trailers, there is the only one force that is pulling this upward, that is the tension in the cable. Okay, this is moving upwards because of the tension in this cable. So the upward force over here for the trailer is T, and then the backward forces, there are two backward forces. One is the friction on this, which is 100, okay, and the second is its weights component. And I'm just going to remind you guys that we're using the weights component over here because we are not talking about the potential energy right now. So we have to, whenever it is about F equal to ma, this is basically we're applying the F equal to ma. This is the resultant of all the forces on the van, and this is equal to its mass times the acceleration. And similarly, this one is the resultant force on this trailer, and then that is going to be equal to 300. Sorry, this is what is its mass? 500. So it's 500 A. So if you solve these two equations simultaneously, you can get to the tension. Now how I solve this very smartly, I just multiplied this equation by 6. Okay, you see that this is 1250 minus this 300 minus T minus 30,000 sine for this 3,000 A. I multiplied this equation by 6 because I just wanted to get rid of this acceleration. We don't need to find the acceleration, I think, yes. So we only have to find the tension. Okay, so therefore I multiplied this equation by 6. This is 6T. I should write 6T over here, and this is minus 600, this is going to be minus 30,000, this is going to be 3,000, and I'm going to change all their signs. You will see that this, and this, these will be cancelled out. So I'll have 7T, that is equal to 1550. So when you divide this, you must get 221 point whatever. So this is the tension in the cable over here. Alright guys, so this was your question number 6 from the November 16 paper, variant 42. So thank you very much. I hope you understand this. Do share if you have any other friend of yours studying A-level mathematics, and try to subscribe as well. Thank you very much.